Hello everyone. In this video I'm going to talk about Microsoft SQL Server and MySQL. Currently you are able to see MySQL here. So in this we had a database which I have just executed, and let me refresh it. So we have the employees database in which we have departments table, department employee, department manager, employee salaries and titles. All these tables do we have. Okay, and in departments, let me start showing you one by one. Select star from employees, so select everything from employees. So everything is shown. So we, how much rows we have? We have 3 lakh rows and 3 lakh 24 rows. So, and let me show you this. In this departments table we have 9 departments. In department employee table we have again 3 lakh something rows, and we have employee number, department number, from date to date. Then let me show you department manager. We have employee number, department number, from date to date. Then salaries, we have 9 lakh rows and we have salaries of employee number. We have actually increment year wise salaries, 1986 to 87, 87 to 88, 88. These are the salaries of employee 1001. So we can assume that our employee number would have more than one salary columns, because its salary also increases every year. Similarly, we have titles. We have senior engineer, staff engineer, assistant engineer. All these kinds of titles we have, job titles. So in departments table we can see that here as well, like we have department number, character type, department name, variable character type. Then here also in department employee we can see that employee number is primary key, department number character, and from date to date type. So we have also the data types we can see from here. These are the columns. All these are the columns. Okay. So I have shown you the command select star from. Yeah. So I have told you about. I have shown you all the tables in the employees database. Now let's start our data definition language. So in data definition language we create table first. So I have created table name emp, and emp id I have taken integer type, primary key which I have set it. Then I have salary, I have taken varchar, and we take usually 255 because of it is going to take the same amount of space. If we take up to 255, if we take up to 256 or 255 or more, then it will take more space, so that is why we take 255. So let me just execute this. So we can see that one row is affected. Now let's select star from emp. Since we have just created the table and we haven't insert any values into it, it is showing null. No, oh sorry, it is showing not showing anything. It is not even showing null. And let me add some values in it. So for that we use insert into emp id salary values. We have the first column, then second column, then first column, second column, similarly. So the one here is the EMP ID and this is our salary. This is again the EMP ID and this is our salary. So this is how we insert into values. So we can specify this by giving the brackets. It is easier for the our explanation that the first value is going to EMP ID and the second value is going into the salary. If we have, so let's suppose many columns, and let's suppose we have 15 columns, and in that we only want to insert the value of 5 columns. So what we will do, we will just give those 5 values here inside in the brackets and simply add the values. Okay, so let me just execute this one. 3 rows affected, and let me execute this one. Now we have our employee ID. These values are inserted into our table. Now let's suppose I want to add more columns. So the command I will use is alter table employee, add the column name, which is I have taken city, then another column name, which if we want we can add more columns. I have only taken 2 columns. Another is country. The city and country I have added, and I have given the data type of variable character, which I have already explained. Alt table is the command. So let me execute this one. So if I see my table now, you can see that city and country are added, and by default the value is taken to be null because we haven't inserted any values. So if you want to insert values into it, what we have to do is to update our table. So we have to use the command update table emp set city something name some name and the country also something name, where emp id is equal to 3. So we have to specify which row are we going to insert the value in. So we in where condition we provide one column name and the row name in which we want the value to be inserted. So that is how our values are getting inserted here. Let me run this one, and let me run this. So the city and the country are the same values which I have given here. So similarly, let me insert the for the second also, and let me see the table again. Now in the city and country I have given some arbitrary value. Let's suppose I want to add some null values as well, where the emp id is equal to 3. Here in above I have specified that the emp id is 2, that is why it is the value is set here. Otherwise if I have taken 3, then the value would have been updated here. Okay, and so let me run this one. So salary is null where the emp id is 3. So emp id is 3, now salary is null. Similarly, if we want to delete from employee where the emp id is 3, so basically what we are doing here, deleting our rows. So let me remove just our third row. Execute, then run this, then you can see that the third row is removed. So if we want to drop a column, then or remove a column, then we use the drop column command, alter table emp drop column country. I'm removing the country column. Okay, let's see. Yeah, so the country column is removed, and if I just want to drop my entire table, I use the drop table emp and run this. So my table is dropped, and if I select this again, select staff of emp, it will show me error because there is no table emp because we have dropped the table. Okay, so these are all the commands that we use in the data definition language or DDL. So we create our table, we can alter our table, we can insert values into it. Or in alter table we can add and drop columns. In insert we can add values. In update we can update our values by using set. Okay, and if you want to delete a row, we use delete from emp, where row id emp id is equal to 3, where the row uh, emp id, whichever row you have to specify, you can give any value of it and it will remove that row. Okay, that is all for our data definition language. You can take the screenshot of it. Now let's move on to the practice part. So I will explain you one by one. So we have, let's say, select star from employee. Let's run again our employees. So we have EMP number, birth date, first name, last name, gender, and hire date we have here. So I have just executed select star from employees. I have selected it and executed it. And this is actually my SQL workbench. So in this I can execute by doing this and pressing this, or what I can do is just click anywhere in this query and just click on this, so it will run only that query, and this designates that the query ends here. It is necessary to end the query in MySQL. It is not so necessary in SQL Server. Okay, so here I've selected the employees, where the first name is Elvis, and order by employee number descending. So the first name is Elvis and employee number is ordered by descending order. So getting from the highest to the lowest. So we have how many employees? 256 employees named first name Elvis. So we have 246 employees having the first name Elvis. Okay then. Select star from employees where the first name is Kelly and gender is female, ordered by the last name. Let's run this one. So we will get the Kelly having the female gender. Kelly having the female gender. First name Kelly having female gender. So we have 86 rows. Okay. And the next command we have select star from employees where the first name is Aruna or Kelly and the gender is female. So let me run this. So either the first name is Kelly or it is Aruna, but the gender is female. So in our SQL, the and is given more priority, meaning these we have taken the brackets. That is why it is taking these two together. Otherwise, if we don't have the bracket, then this code will get the first priority, meaning the first name is Kelly and gender is female, and Aruna can be male or female. If I run this, you can see that we have gotten 292 and previously we have got 167. So, and you can see that Aruna is also male. So in this, what happens is actually our and get the more priority. So first this is getting solved and this, after that this. So what this means is that it will take the first name Kelly and gender is female, and other it will take all Aruna name irrespective of their gender, which we don't want in this query. We want that the first name and the last first name should be Kelly or Aruna, and both of their genders should be female. So we use brackets here. Okay, now we can write as many names as we want, like first name is equal to Aruna, first name is Kelly, or first name is equal to something else. So we have to write. So instead of that, we can use first name in. We can provide as many names we want here. So it will get where the name is John, Mark, or Jacob. So it acts like or. Instead of giving first name Aruna or first name Kelly, we can use like in Aruna and Kelly here. And this one we are getting the first name John, Mark, and Jacob. So let's run this. So we have Mark here. Whosoever name is John, Mark, and Jacob will come here. So coincidentally this time we only have mark in our database. So this and this, the above command and this command both are same, both will give the same result, 230 rows and 230 rows. Okay. Then we have the wildcard characters. When we are using the wildcard character, we use like. So what does this mean? This means that I have taken a string in which I have given a percentage sign. So this percentage denotes x number of characters. So any number of characters can come into it. After mark, anything could be there. You just give me wherever it starts from the mark, and after that anything could be. So when I run this, I will get the marko, marky, or mark. So after the mark, it should start with the mark, but after that, a percentage sign means any number of characters can come into it. Similarly, from employees where the hire date is like 2000 x or percentage sign, so x number of characters can come here as well. Let me run this one. So it is simply means that the hire date should start with the year 2000, and after that any month, any date. So we are getting any month, any date after that. Okay, so remember that we use the like operator for specifying the for getting the for using the wild character and getting the values. And another wild character is underscore. This only get us the one digit value. So where employees EMP number should be starting with 1000, and any number 0 to 9, any number can come here. So if I run this one, so only remember this difference, that in underscore we only use the one character, and in the percentage we use multiple number of characters we can use. We can have, I mean. Okay, so in this one we are having employee number starting with 1000 and 1 to 9, because if it is 10 then this digit is going to occupy, which we don't want, and so that's why it is not getting us any value here. And we also are not getting 0 here. 0 can also come. The employees, there is no such employee number as 10000, 4 times 0, I mean. Okay, so this means percentage coming front and back means the we can have any number of characters in the front of Jack and in the before of Jack. So Jack can be anywhere in between. So let's run this. So we have used not like, so it means that it should not contain anywhere Jack should not be there. So we are getting these many rows. If we just remove the not, and we can see how many rows we are having Jack. So we have 256 rows having Jack in it, Jackson. So if we use the not like, so we will get all the rows not having Jack in it, which means minus the 256 value. Okay, so 3,24,000 minus 256 is this number. Okay then. Moving on to the practice 2. Let me just space it evenly. So that it is more visible. Now select star from salaries, meaning everything from salaries, where the salary is between this number and this number. So 666,000 or 66,000 and 70,000. Order by salary descending. So this our salary will be ordered descending wise. Let's run this. So wherever the salary is in between the 66,000 and 70,000, all the values will be returned. And the least value is 66,000. Max is 70,000. So we have 74,027 rows returned. So meaning these many rows have salary in between this range. So Moving on to the next one, where employee number not between. So we will select everything from employees where the employee number not between 10004 and 10012. So 8 values are in between. So except all these 8 values, every other value will be returned. So 3 lakh minus 3 lakh 24 minus 8, we are getting 3 lakh 24 minus 8, or we are getting minus 9. Why are we getting minus 9? Because this value is also taken and the last value is also taken. It is both values are taken, so one value is additionally added. Let me show you what I mean by that. Let me just remove not and just run this. So we will get 9 rows because we are getting 4 and 12. So if we subtract 12 minus 4, we get 8, but that value is also included, so that is why it is 9. And so all the rows minus 9 values if we use not between, sorry, not here, not between. Okay, so 3 lakh 15. Now similarly we can use not between the department number. Should we will get anything between the department number D003 and D006. Okay, this is between, not between. Okay, select star from departments where the department number is not null, order by department number. So let's run this. So all the departments which are not null is not null. So is not null we use if there is to find that if there is not any null value. So we don't actually have any null values in our departments table. That is why it is showing all the values, which are 9 values, and it is ordered by department number. By default order is ascending. If we specify descending, then it will do descending. Otherwise, if we just simply use order by the column name, it will do it by ascending. Okay, select staff of employees where the hire date is greater than this and gender is female. So wherever the hire date is greater than 1st January 2000, it will show, and the gender should also be the female. So this is also done. Select staff from salary where the salary is greater than 15,000. The wherever the salary is greater than 15,000, it will show, and it is not ordered by anything. So we have 16 values returned. Select distinct hire date from our employees. If we do that, we will get the distinct values or the unique values. So any hire date is not getting repeated. These are the unique values. So these values are not getting repeated. It is 5434 values, and if we just remove the distinct from here and now run it, then we will get 3 lakh 24. So in 3 lakh 24 rows, hire date we have only 5434 unique values. So DISTINCT, distinct. So these many distinct hire date we have. Then we have the aggregate functions. Select count star count everything from the salaries where the salary is greater than 10,000. If we want the number of our employees having the salary greater than 10,000, we calculate it by this. So if we run this one, so we are getting 9 these many amount of number, which is basically 9,67,330. Yeah. So these many people have salary greater than 10,000. So we have aggregated function here, count. Select staff from department managers, showing all the departments manager. Count every department manager. We have 24 department managers. And select star from employees with a higher date descending. We can also order it by a higher date descending. So our it is showing descending higher date. Okay, moving on. Now in this you have to remember this order. Select from where, group by, having, order by. So in this order we write the query: select, then from, select what, columns, from, where, from table basically, where the condition, group by, the column name in by which we have to group by, having the aggregate function which we will talk about. In having we only use aggregate functions, otherwise it would every if we use columns condition, then it is going to come in the where. Okay, let me explain. So when we are using where, we write the condition after where. So where this condition, where this is equal to true, or within, between, in between range, where we, after where we specify the condition, after select we specify the column names, after from we specify the table name. Table is only one, column can be many, and where we specify one condition or many condition. Group by, we can group by one item or many items depending upon how many times we want to group by. Having, after having we use aggregate functions. When we use aggregate functions and we have to do some operations in it or apply some condition in the aggregate function, then we use having. Then order by, you see that we can do ascending or descending wise. Okay, so in this query what we have taken the salary, count of employee number, as we have given the aliases as. So this as means an alias. Alias means we specify this column name, which is the count of employee number, as the employee with the same salary. Okay, from salaries, where the salary is greater than 80,000, and the group by salary, we are grouping our column by salary and ordering also it by salary. So let me show you. Let's run this one. So we are getting the salary and the count of employee number as this name. So this name is come here. So that is the meaning of the aliases. Let's just change the column name. If we remove this here, then this will only show. But in SQL Server, we have to use the aliases, otherwise it will show us error that you have not given any aliases. In MySQL you can do that without giving the aliases. And where salary is greater than 80,000, so these are the salary which are greater than that. And we actually, what we did here is count the employee numbers with the salary greater than 80,000. So 80,000 in one salary we have 10 employees, 80,000 in two we have 10, similarly 10, 10, 13, 15, so on. So this is giving the number of employees per the given salary. Okay, so this salary have these many employees, and this salary have these many employees having the same salary. This salary has these many employees having the same salary. So this is what we get from it. Okay, so moving on to the next one. Select star average salary. Star means everything, comma, average salary as average sal from salaries, where the salary is greater than 1,20,000, group by employee number. Let's run this one. So everything we have selected from the average salary or from the salaries table, and we have taken another column named average salary, which is an aggregate function which calculates the average salary of each employee, and we use the group by employee number, so it is grouped by employee number. So this employee number is average salary is this employee number average salary is this. So these are the values that we are getting. Okay, I think this should be clear. So where we have the condition group by which we have to group by. Yeah, before that let me tell you, select star from salaries. Let's go to select back and select star from salaries. If you remember correctly, I've told you before that one employee number is having the many salaries. So in that query, what we were doing was just group it by all the same employee number and give the average salary of the employee number by employee number. Basically, that we did here. This is done. We were here. Yeah. So that we did here. And yeah, that that we did here. So it is sorted by employee number. Now select everything from the salary, average salary from salaries group by employee number having salary greater than this average salary. So we are specifying the average salary. Other if we specify the salary, we use where the where clause where, and if we specify the aggregate function within it, then we have to use having order by employee number. Let's run this command and see what happens. So we are getting everything same. Previously we got the 807 rows, and this time we are getting average salary, having the average salary greater than this number. Previously we were getting all the salaries greater than this number. Now we are getting only the average salary greater than this number. Okay, so this is the difference, and I hope you understand. So moving on. So in this select we have used an employee number, salary, average salary from salaries. So remember this, whenever we use our aggregate function, the columns that comes with it goes into the group by. Okay, so in this one we use the employee number as our group by. So let's run this. So we grouped it by employee number. So this what tells us this employee number having this salary, average salary is this employee number average salary is this. We actually don't need the salary column because it is not giving any sense, because salary are multiple, the average salary is what we want. So let's remove this and let's do it again, run it again. Now it is making more sense. So per employee number we are getting the average salary, per employee number average salary. Okay, where were we? We have done this query. Yep. So now moving on to this query. So employee number from date and count of employee number from employee department employee where the from date is greater than 1st January 2000. Okay, and group by employee number having count of employee number greater than 1, order by employee number. So basically what we are doing here is taking these two columns, making this column, we are not giving it any aliases. From department employee where the from date is greater than 1st January, this group by employee number. Oh, like first let me just show you. So we have grouped it by employee number and we have counted the employee numbers. So and order it by employee number basically. So we have ordered it by employee number and grouped by employee number. Then we have taken the from date of it and given the count of employee numbers where the count of employee number should be greater than 1. Having so where we want all the employees having the count of employee number greater than 1 in this, or who has, and also who has joined after 2000. So this is the sense we make out of this query. And all these queries which are here, I have it in the question bank of it, which I will list in the description down below, or yeah, I will list in the description. We have some questions related to it which you can do for practice, which I will put a link of it, of the all the zip file, a link of the zip file. Yeah, okay. So moving on, in the MySQL we use the limit, in SQL Server we use top, both are used for the same function. In select star from department employee where the limit is 100 means only 100 rows will be returned, and it is not ordered by or grouped by, it will just return me the first 100 rows of it. And if the same query is to be run in the Microsoft SQL Server, then we have to write this here before the select star, and we have to write top 100 like this, but we are not using here. This is MySQL, not SQL Server. I will show you after that SQL Server. Okay, so let's run this. we will get only 100 rows. Yeah. So count employee number from department table. Let's see how many employees. These many employees we have. Count distinct employee number. Let's run. So these many distinct we have. Count distinct department number. These 9 department we have. Distinct department number from employees. These are the distinct department number from employee. Distinct means unique department. Distinct means unique. So unique means the non-repeating values. So all the values which we get after distinct are the non-repeating values which we have in that column. Okay. So select sum of salary from salaries, where the salary from date is after 1st January 97. Sum of salaries we will get after this date. Okay. Sum of average salary from salaries, where so sum of average salary we will get here. Okay then. Select a round average. We can also round our values by using the round function, giving this is a value and we will round it by 2 decimals. So this will round it by 2 decimals, and from the salaries, where from date is after this. Okay, same thing, but it will just chop it or trim it to 2 decimal places. Let's run this one. 2 decimal places. It is rounding off. And select sum from average salary from where the salary. This is the same query I think we did above. Okay. So we have also the aggregate function min and max. So yeah, I forgot to tell that this is an aggregate function. This is an average aggregate function. So min, max, round, sum, average, min. These are all the aggregate functions. So we can get the minimum values from the minimum employee number from the employees table and the maximum employee number from the employees table. We can use it in any column. Here we have used it in employee number. So save. Okay, so now we will start to talk about joins. So let me show you. We have creating a department manager duplicates. So drop table if exists, department manager duplicate, create table. These are the columns and insert into values. Insert values these. Select delete from the, so we actually what we did was we altered the table and created a duplicate of it, and after that we did some alterations. Similarly, like department manager duplicates, we created a department duplicates, and we did some alterations in it as well. Let me just select it all and run this one. Now it is created. Select it all and run this one. Now it is also created. These are the some null values which we have added here, and these are all the values having some null values which we added here. Alright, so it is not showing duplicates value here as of now. Let me refresh it. Now it is showing the department duplicates and department manager duplicates. Okay, now we will perform some joins. So inner join first of all. In joins, first of all we see after the from which 2 tables are we joining, and the syntax is something like this. So department manager duplicate we are joining with department duplicate. Okay, and first of all we select see which tables we are joining, and we provide aliases to them. So department manager duplicate space m, meaning as m. We can also write it as m, or we can just simply put a space in after it and specify it as m. And similarly we have given the alias of department duplicates as d, and on it, and we have joined these 2 tables on the basis of a primary key or the common column which we have. So if we see our department duplicate, we have employee number, department number from the to date, and departments we have department number and department name. So in both we know that we have department number, so on the basis of the department number we have performed the join. So we use this one is left, which is in the left of the inner join after the from. These are the 2 tables we are joining. So remember that after the from the table name came. So these are the two tables we are joining basically. So that is why we have taken two tables here. And on we are joining it on department number. So you can see that I have specified here m dot department number and d dot department number. So m dot department number is telling me the department manager duplicate department number. Take that. And d dot department number is telling me department dot duplicate dot department number. So it is in this one it will take the department number from this table M table, which is the department manager duplicates, and this next one it will take from the D table department duplicate, and then join it. Okay. Similarly, if we see above, we have taken M dot department number. So from M table, which is our department manager duplicate, we have taken the department number. From M, we have taken the employee number, and from the D, which is the department duplicate, we have taken department name. And on these three tables we have performed the join. If you can see the department, let me go back and show you. So we have 11 rows that were returned here. Let's start from department duplicate, run this one. So 26 rows we have here, and select start from departments duplicate, and 11 rows we have here. So we are joining these two on the basis of the department number. And in inner join we know that only the common values will come. So when we perform inner join, only the common values will come, and order by M department number, which we are ordering by the department number. Let's just run this. So there will be no null values in the inner join, because the common values, whatever the common values we have, that only will be returned out. So wherever the department number is D003, it will give me all the values in relation to the this. So in this you can see that there are two threes, and in this you can see that is only one three, department D003. So what it did is that it has taken the both from the left and this from the right, and it has given the department name to, if it has seen this, and given this the name of human resources. So if we go to D003, it will give us the human resources. Similarly, if we go back and let's say we have taken D008 research, so when we do the inner join, so D008 is research, so we have two rows because in our department manager duplicates we have 2008. So this is how we see our inner join. Similarly, one thing which also we can do is that we can take everything from the M and everything from the D, and then perform the same join that we have performed earlier on the same key which we have performed. This is the key on key. Key is the common value which is on the basis of which we are joining two tables. Order by, we have given the M dot department number. Okay, let's run this one. So basically it has given me all the employee number, department number, and everything from the left side and everything from the right side, and we have taken and we have performed the join. So in this is the inner join. If we write the inner join, or if we simply write the join, it means the same thing. It will perform the inner join itself. If I remove this and then run this, or maybe just click here and run this, then it will perform the same join. So it is the same thing. All right. Moving on to the next query. Now we have taken here the employees, which we have given the alias E, which is we have taken the left side of our join, and department manager we have taken on the right side. On those both we have performed join on employee number, because in our employees and department manager, if we see department manager, employee department name from the to date, and employees. So employee number is common in these both, so that is why we have taken the employee number and performed join on it, and we have taken the employee number as the key. Okay, so employees is at the left of it, and this department manager is on the right of it. From it we have taken, from E table, which is employees table, we have taken employee number, first name, last name, hire date, and from the department manager table we have taken the department number. Okay, and we have performed the join by employee number. Let's run this one. So it has taken these values, these columns from the left side, and this column it has taken from the right side, and perform the join. Okay, and where order by it has given the employee number. So this is the order in which we perform join. Let's save this. Moving on, similarly we can perform the left join, right join, like this. Okay, so I have taken everything from the E and everything from the department manager, and I have given the where condition also here, that E dot last name should be Markovich, and order by I have given the E by employee number. If I run this query, it will give me the inner join of uh, it should have the Markovich in it, the last name should be Markovich. Okay, now if I run this one, these are all the names which we are getting the last name as Markovich, which is not required here, but I have just did this because I wanted to know how many people have the last name Markovich in. Okay, so yeah, so this is our inner join. It is giving us only one value. So let's see our left join. If we do the same query and perform the left join here, then we will get the output. We have gotten 181 rows. In these 181 rows, we can see that only one row we are having all the values, and the rest of it as null. So as we know that if we take our left join, it will take all the values from the left, and whatever the values that are in the right, it will take as null. Okay, and if we perform the join on it, so that is what it has done. And if we perform the right join, if it will take all the values from the right, and whatever the values that are not in the left, it will show. Control. So in the right join, when we perform the right join, it is only going to give us the one value, and it will take all the right part of it, and whatever that is not in the right, it will not take, and it will show the null values in the left. Okay, yeah, so I think that clears the left join, right join, and the inner join. And let's see the next which we have. Say staff and department manager, E employees, and everything we have taken and performed simply join in it. So what it will do, it will give us the inner join. I have explained you before that if we just simply write the join, not specifying the inner or left, it will only do the inner join. So let's do this. So we are getting the 24 rows. Here we have not specified any where condition, so these are all the values that we are getting out of it, because in the department manager we have 24 department managers we are having, and in employees we have 3 lakh rows, and out of which these are the managers that the entire data of the, not the entire data, but the department manager and employees data joined together we are getting. Okay, and that is the inner join. Basically these both are the same. And yeah, there is another way of doing the inner join. So this one at the top, the 34th one, this is the old method. The one which we were using is the new method. So in the old method, what we did is select E star D star from department D and employees E. You can see that we are not performing writing any join or anything. We just specified a comma in between. So what it will do, it will take this and this and perform the inner join on it. And where we are not giving on, we are specifying where the E dot employee number is equal to D dot employee number. So this is the old syntax, we don't use this. So this is the old syntax, we don't use this syntax as of now anymore. But you can see that this also works. Let me run. So 24 values again. So this is also working. And if we take the join syntax, the join employs on this, so this also works. Yeah, we are getting the 24 values. So these two are the same thing, but the above one is the old syntax and the below one is the new syntax. Let me just space it and show it. It looks a little bit more spacious. So you can go through this, or you can take the screenshot of it if you want. Okay, now so I'm moving on to the cross join. After that we have the outer join or the cross join. Yeah, we can also perform like outer join, and let me just copy this and perform the outer join here itself. Basically outer join will give everything on the left and the right. So it in this case outer join is not giving full join. Okay, yeah, now it should show from this. What is the problem with you? This is done. Full join is not taking the parameter. Wait a second. Yeah, full outer join, I guess. Error. Outer join. Error. Still error. Yeah, when we perform the outer join, let me see. Wait a second. If we have outer join, so it is telling me that MySQL does not support the full join. In MySQL, you can do the full join. So you can do the union of it, which we will discuss after we discuss our joins. So it does not support uh, full join or outer join. So that is all of the left and right joins, and now we move on to the cross join. It has the same syntax, but the only difference being in the cross join, we cross multiply the two tables, meaning the left table if n columns, and basically if we have a left table with n rows and m columns and the right table with n rows and m columns, it will multiply the intersection of it, and basically the same, it applies the same criteria which we perform in the matrix multiplication. So the common values which we take is the output of that matrix multiplication. So if you remember from the 12th class mathematics, if we have let's say two in the first table, we have in the first matrix we have 2 rows 3 columns, so 2 cross 3, and in the second one we have 3 rows and 6 columns, so 3 cross 6. So with the output of it will be 3 cross 3, which is the center of it. Okay, so yeah, basically what happens here is it cross multiplies with every row, so it will give us the value that is the multiple of the rows we are having. Okay, so in this we do not perform on, no on is performed here. So let's see titles. So we are getting all these titles. I've shown you this before. Select employee first name, last name, hire date, title. These we have taken from the left side, which is the employee side, and we have taken the titles, and we've taken the titles from it, where the first name is Margaret and the last name is Markovich. So wherever there is Margaret or Markovich, we will get the output. Let's see how many output we have. So we have basically we have performed the cross join, so it will just multiply it with all the titles that we are having. Yeah, so it is giving us the 4 lakh values. So Margita Markovich is cross joined. Yeah, so you can see the only difference we have is we don't use on here. So we have used this from this table, join this. Previously we used to use on the key. So in the cross join we don't specify the key because we don't need the key. because it is not of no use. When we perform the cross join, it means that the first table you multiply with all the rows that we are having in the next table. So the all the rows from the first table will be multiplied with all the rows of the second table basically. Yeah, I have explained this much. I think this much should be enough. Now moving on to the next one, cross join, inner join. Okay, let's see. This one we have performed the cross join. Okay, so 36 rows we are getting. Okay, so basically what it is, it has taken the departments and department manager. In departments we have 9 departments. In department manager we have 24 department manager. So we have performed the cross join. We haven't performed on anything, and that is why it is showing where the department number is 2000 D009. So it will take the D009 and multiply it by all the 24 department managers. Yeah, that is what it did. Okay, so if we specify inner join and we write a where condition, this is same thing basically, intersection that we are trying to find out. So these are the unique values we are having. So these are the inner, after the inner join we will get the common values which are in the both the table. Okay, which we have already talked about. And in this one, let's see what we have. Inner join department, same thing without a where condition. So we have 24 rows we are getting as an output. Okay, now select E star and DM star. So employees E and department manager DM. So we have taken everything from the employees and the department manager. We have joined it, cross joined it basically, and order it by employee number. So it will give us a output, a big output it should give. Nah. So this in this what I'm trying to explain. If you write the cross join and after that you perform on, which we don't use, cross join we don't use on. So if you specify on after it, then it will understand it as an inner join only because you have used on. So on key you have given, that means it is performing join inner join. Otherwise, it will take the cross join. If you have not taken this and uh, let's see, I'm writing the cross join here. If I don't write cross here, okay, and just simply execute this, it will take the cross because I have not specified the on. So it will take some time because it is going to multiply the employee with the department manager. So basically it will give us 3 lakh into 24 times. Yeah, that much. So 3 lakh into 24 is 48 and how much it is? 24, huh? 72. 72. Okay. So 3 lakh into 24 is 72 lakhs. Yep. So 72 lakhs values we will get. So that is why it's taking a long time. Yep. You can see that 72 lakhs values we are getting. So it took a lot of time. So let's start from department manager. Yeah, this is not needed. Okay, so with this we have done our cross join. So just remember that in the cross join we don't use on. Okay, we don't use on. It is a cross join. I have told you about the left join and the right join. Let me tell you again, whatever is in the left of the join we are performing, it will perform the left join on the left part of it. So the left join will be performed in the employees, and this is taken as the right. Okay, so if you take this and shuffle this and put it here, you'll provide left, and the next one you shuffle it and you provide right, but the output of it will be the same because uh, in the first one you have taken left join and you have taken it and employees at left. In the second one you have performed the right join, but you have taken the employees on the right. So don't get confused with that. Whatever is in the left will be the part of the left, and whatever is the right will be the part of the right. So that covers our joins, most of it. Now we have the bigger join, which we call the multiple join. So basically what we do here is we join multiple tables. So we have taken employees, then department managers, then departments, and we have taken titles. So we have taken 4 tables. On those 4 tables we have performed join on, so employees and department manager we have column employee number, and department manager and department we have call common department number, and in departments and title we have common employee number. So that is how we think in this. So first 2 table common, after it, then second 2 table common, after it, then third 2 table common, after it. Okay, then where the title is manager and order by this. Okay, let's run this one. Okay, employees.title does not exist. Why is that? Might have been I have made some mistake. Yeah, that is why I have copied this, I think. Okay, let's see. I have taken employees. Okay, department managers on e join. This one, ठीक है. Okay, then employee number, then department. Okay. Yep. Then titles, then where manager, and order by this. So I think this and above is exactly same, just the difference being is that this is M and I have taken this as DM. So let's run this one. Let's see a post. Let's see if this runs. Yeah, this runs perfectly fine. So might have been something that I have not written correctly. Yeah, title is title. Let's see. So it was giving us the error that employees don't have title in it. So we are not even giving the title to the employees, are we? Employees department manager, employees department manager, departments titles, department titles, still T dot title, T dot title, E dot employee number, E dot employee number. Still we have getting the issues. I don't know what is the issue. So no issues. Okay, so yeah, so I just wanted you to explain that we perform join like this. Let me repeat again. Employees E, department manager M, we perform on these 2 tables, we perform join on this. These 2 tables we perform join on this, and these 2 tables we perform on join on this. Department employees and department manager is on employee number, department manager and departments on department number, departments and titles on employee number again. Okay, yeah, another thing that I wanted to tell is moving back to our inner join, you can specify this as m dot department number is equal to d dot department number, or d dot department number is equal to m dot department number. You can shift the order of this, it does not make any difference. Okay, after on you can shift any order, but remember that if you shift the order of this table, basically these 2 tables, then that will specify whatever the join you are performing. If it is left join, then the left is that, and if it is right join, then the right would be that. Okay, so these are the things that you should remember in this. Rest all everything is covered. Let's run this again. So this is the biggest query we have until now. We will have more bigger queries in the future. Let's see. Okay, so in this we have performed join on 4 tables, and so because we are joining 4 tables, we have to use 3 keys only. So because the join is performed in the middle of it, and if we take 4 stacks of boxes and join them, we will join only 3 times. Yeah, you got that. Okay, so the same logic works here. Yeah, so that ends us with our joins. Now our joins are done. So next we will learn about subqueries. Okay, so now let's start our subqueries. So subqueries is a query within a query. Okay, so nested queries you can also call it. You can call it subqueries, but we mostly call it subqueries. Okay, so let's see the syntax of it. So we are selecting everything from the department manager where employee number in this table. So department, this table, in this table we will output select employee number. So whatever the employees we number we get from this, which is where the employees hire date between, where the hire date is between 1st January 1990 to 1st January 1995, so 5 years. So if the data is in between, the hire date is between, it will give the number of employees that are having the hire date in between this, and that number of employees will get feeded in this employee number, and it will give everything from the department manager where that employee number exists. Okay, so first let's run this query and press this one. So you can see that we are getting all the employees number that are having the hire date between 1st January 1990 to 1st January 1995. We are getting 1 lakh, about 1 lakh rows. Okay, and if we perform everything in it, then 1 lakh rows we will get from the department manager, but in the department manager we only have 24. So if we run this, we only get the two values. Why do we get the two values? Because out of those only two were the managers, all the others were just the employees. Because in our department manager there are 24 members, and all those 24 members are the managers, and in our employees data we have 3,24,000 employees, out of which 24 are the managers. Okay, yeah, that is very much clear. So the output of it that we are getting is only 2. So only out of all these managers which are having the hire date between 1st January 1990 to 1st January 1995, only 2 managers have the only 2 managers are, there are only 2 managers. Yeah. So okay, next one, let's run this. I think this one is it is working. Okay, so this is where exists, this is a little bit advanced, I guess. Where exists, it means that if this table exists, let's run this one, then it will give the okay, so this will not give us the output. Yeah, it is telling us something. Yeah, because this is will not run like this, because we have taken employees here, and we have taken titles here, and so what we are doing is performing the join on the titles, and yeah, titles from titles and employees. We are doing it in the nested way, and yeah, where the title is assistant engineer. So this actually works, both are the queries runs at the same time. That is how we are getting the output. So we have some complex subqueries as well, which we can perform, and similarly we can perform the queries. So we will discuss more queries, subqueries in the Microsoft SQL Server, which we will do a bit later in this video. Okay, moving on to our F case. Yeah, so okay then, so let's talk about if case. So we use the if case after the select, after choosing all the columns we want, and finally we provide or generate a column. In this case we have generated a column called is manager. So this is manager case when dm.emp number is not null. If this value is not null, then manager, else employee. So what it will do, it will take the department manager table, which is we have joined where in the left we have kept the employees with E, and then the right we have taken department manager with DM. We know that in department managers we have 24 department managers, and employees we have 3,24,000 employees. So all the 24 managers will get the manager, and all the employees will get employee. So we have created an case when statement, case when dm.em is not null. So this is our first condition. If this is true, then this, then manager, else employee. Then we end as we have given the aliases is manager. These are the 1, 2, 3, and this is the fourth column which we will get as an output. From employees department manager, join on employee number department manager where employee number is greater than this employee number. So let's execute this one. So you can see employee number we have got, first name, last name we have got, and is manager is the condition that we have specified. Now if this is an manager, it will give as a manager. If it is employee, it will give as an employee. Okay, and let's show you that we have 24 department managers. So out of these, only if we get out all the managers from it, and then we will only get the 24 managers with all their details from the employees column. Okay, I guess this you got it. Now similarly in this we can also do it by this. If emp number is not null, then comma manager, else employee, as is manager. So it is already, it all has been done in the one line itself. We haven't used any case, when, then, else, and anything like that. But this if condition will only work in MySQL. It will not work in Microsoft SQL Server. So in Microsoft SQL Server, only this will work: the case, when, then, else, and as. So in Microsoft SQL Server, this will work, case, when, and in this we can use both, if also and case, when also. Okay, so this query is the same query as above, and let me run this again. 234 rows we have as an output. Okay, now so moving on to the next. In this we have taken employee number from employees table, first name, last name from employees table. Then salary we have taken from the salary table, and s dot salary min and max we have calculated as difference of that we have calculated as difference salary. And then we have used another column, case, when max salary minus min salary is greater than 30,000, then yes, else no. So this will tell us that if the salary is greater than 30,000, then it will show yes, or else it will show no. Meaning else being that whatever the salary is not greater than 30,000. As criteria, so it will show as the criteria, employees and salaries are being joined on employee number, and it is grouped by employee number of the salary. Okay, so let's run this one. So we have gotten 1 lakh rows, and the criteria we have also gotten whatever, like if this is greater than 30,000, then it will be yes, otherwise it will be no. Okay, so I think this must be clear. And yeah, another thing I remembered which I didn't tell you before. Moving back to our practice 3, in when we use having, where is having? Here we are using having. So in having, when we have to specify any condition, then whatever the alias we give of it, if let's suppose I have given this average salary as an alias of something, I cannot write that alias name here in the having. Okay, so I will give the average salary itself. So in the condition I will not give the aliases. In the having condition we will not give the aliases. Okay, so this is another thing that you should remember. You have to write the condition itself like it's an average salary here, so you have to write the average salary. So moving back to our KSF statement, this is done, and this is also the same thing. Okay, let's run this. Same thing, no different thing. What have we done differently here? different salary we have calculated. Yes, no. Okay, so in this way I have taken the DM EMP number, first name last name from E, and EMP number we have taken from E here. Okay, that is why. So if we take the department manager employee number, because we only have 24 employee numbers in the department table, we only get the 24 values out. So this is the difference. So it is important to keep in mind what you are taking while you are inserting it in the here in the select. So we are if you are taking from employee number, then it will give you more output because it has having more number of employee numbers, and just because it is having less, so it is giving us less output. Okay, so in this way we got that in the departments table we have these many of the managers are getting the salary more than 30,000, rest are not getting that much. Moving on, the same condition we can apply using the if statement. The same condition is like we have taken a differential salary, and remember in wherever we give the condition we don't specify the aliases that we have provided. We write the entire thing. Okay, so entire thing is should come here, and you should not provide like difference in salary here, so it will not work like that. And if this condition meets, then yes, else no, which is called as criteria. So 24 values here also we have gotten. Okay, moving on. D dot employee number, then similarly this, if this is greater than this, then still employed, otherwise not employed. Let's run this. So we got these many people who are employed and the rest are not employed. So which is DE? DE is, let's see, department employee. Okay, and employee number. No, and employees on, we have performed the inner join on, employees kept on left, right, department employee. Then yeah, so if to date is greater than today's date, then it is employed, otherwise it is not employed. Yeah, simple. And we have limited to 200, otherwise if we don't limit it to 200, then it will give the entire output. Okay, similarly this is out of our yeah, sysdate. So this function gets the date of whatever the date is today. Let's run this as well. Sysdate, yeah, it works perfectly fine. So some employees are employed still. So yeah, let me show you the salary column. Going back to the another thing which I remembered that I want to tell you. So let's run this one. If you check the salary column, yeah, not salary, I guess. To date we have given provided like 20,000, some to date like this to date. So some to date is provided like 9999, just because that whatever day you perform the calculation on, this day will be greater than that, so that when you get the output of it, then you can show that with the performing the sysdate that yeah, they are still employed. So this sysdate, what it does is get the current date, which is today's date. Let's see. Okay. Okay, let's select sysdate if we can do that. Let's see. Yeah, this sysdate. Let's run this. Okay, so we got the sysdate as output. So today is 25 June 2022. 25 June 2022. You can see. Okay. So sysdate gives the today's date. There must be some more functions that you will have to remember. So this one being the one you should remember. So this is giving us dd, and then time in hours, minutes and seconds. Okay, with that our if case is also done. I have explained you if case completely. Okay, now this is one another thing which I have created. So I have created a table num1, the column name is n1, and num2 column name is n2. Integer type are both. So we have dropped the table if exist, which we will do copy paste num2, which we will check for both the tables. Let's run this. So these two don't exist, so now let's create this. These two are created. Now select from 1, select from 2, insert into values. So let's insert the values, some values in the 1, run this, and into as well, run this. Now select star from 1, let's do this. 1 1 2 2 3 3 4 4 is in the first, okay, and in the second let's check 1 1 1 1 2 2 3 3 3 3, okay. So these are the two tables I have taken. So now I'm going to perform the left join, inner join, right join, cross join, and join, and we will see the output of it. Okay, let's perform the left join. So what do you think the number of output should be? So in this 1 2 3 4 5 6 7 8 values we have. So the inner join I will tell you first, okay. So this will check this one, join with this, join with this, join with this one, this one with all three of them, then this one with all three of them, then this one with all these three, no, for this one with these two, and this one with these two. So 4 values here and 6 values here. 4 plus 6 10, then 1 2 3 4 5 6 values here, 16, and 16 values should be there. So let's run this. 18. So I did a mistake somewhere. Yeah, so 4 and 4 will also be we will get. So that was the result of the inner which I was telling. So in the left we are taking the left, all the values from the left. So let's first tell the inner one. So in the inner one we are getting the 16, and now let's talk about the left one. So in the left one it will take all, it will join all, do all the inner joins. After doing all the inner joins it will see if there is any value that is not in the right. So 4 is here, so these two 4 will also get added, okay. So in the right join, let's say if we are doing the right join, but in the right join we are not having any such, so it will give us 16 values. Yes, so it also gave us 16 values, okay. And similarly in the cross join it will multiply everything with everything. So what do you think is the value of it? 8 into 8, how much it is? 64. Let's see if we get the 64 output. Yep, we got the 64 output. So cross join it, we don't use on in the cross join, okay. So remember that. And yeah, so cross join we don't perform on, we have done that, okay. And finally what we have done, we have used join, similarly only join, okay. We know that only join perform the inner join, so it will give us 16. Yeah, okay, I guess this explains a little bit better, but there is a little bit confusion in this case scenario, because when we perform the inner join we get the common values, but in this case we are getting the all the values related to that, to the next values. This is because we have only taken the one column, so one column from each. So when we perform the inner join it will see with all the that and try to join with this, try to join with this, it will try to join with this. So when we have multiple columns, we don't have the, we also have like multiple columns values as well, so all those values get unique. So that is why they get unique, and that is why only one output out of all those we get, because all those columns are unique. So if these two are unique, like if these values were also like 1 1 2 2 3 3 3 3 4 4 4 4, then it will give us the how much it will give. Let's create a num3. Okay, let's see. Let's create a num3. Copy, not this copy. Copy, paste, num3. Num3 we have to create. Copy, paste, num3, num3, and this one is simple. This done, and now we will perform the inner join. Let's copy this and let's paste it there, and we will perform 1 on 3, 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 1 on 3. So let's create this, run, and num2 already exists. What the, we have to just run this. Yeah, okay, done. So this is created. Let's insert values. Values inserted. Now let's perform join. Copy, copy, paste 3. Let's first check. Yeah, all these are same. So first and the third have the same values. If we perform the join, we will get like let me think, 4 here, 4 here, 4 here, 4 here. We will get like 16 values still. Let's see, 16. Yeah, 16. Just because these values match and the other values also matching, it is giving like that. But if all the 8 values were unique, it will give it all those 8 values only. Okay, so this also explains something. Okay, just keep on doing the practice with this. The more practice you do, the more you will get. And another thing is that I have taken this is our alias. Okay, the first thing we have the alias. So n_1 is the alias of this, and n_2 is the alias of this, on which we have put the dot on n1. So remember that if there is only one column, we have to specify that column. We cannot use the star. So that is why I haven't used the star here. And n1 is from the n1 table and n2 is from the n2 table, on which I perform the join, and you know the syntax. So that is also I thought I should tell. Okay, so next we will talk about union and aggregation. Okay, so let's first run this one. Let's see what we have. So what we have done, we have taken the gender and we have calculated how many male candidates and how many female candidates are we having. So these many males and these many female candidates we are having from employees table, group by gender. Okay, so again we have used the aggregate function. So when we use the aggregate function, whatever we provide in beside it, we put it into group by. So we put it into group by, and everything is similar. Okay, the next, let's what we have done here. I think we have done the same thing. That is nothing extra. Okay, this. Yeah. So what it had bit what it did. Okay, we have taken the department manager and employees. So and we have joined on employee number, group by e dot gender. Gender is taken from e, and e dot gender we have taken, and count of. Okay, we have taken the DM count, the department managers count. So that is why in the department managers we have 11 male candidates and 13 female candidates. So total we have 24. So 11 are male and 13 are females in the department managers table. So these are all the managers. Okay, now we have, what do we have? We have a subquery, and in the subquery we have provided the union. So yeah, I have to tell you the concept of union. In the concept of union, I have to tell you like in this and as well as in something else. So just keep on hanging. So what we do is we take a query, we get a table out of it, then we use another query, we get another table out of it. Then on those both we perform the union, meaning all the values that are in the one and all the values are in the two, they both will join the way they will append. So one is on the above, the other is on the bottom, so they will like join together without multiplying or anything like that. So they will just add on. And union, what it does is that it removes all the duplicates value as well. If you want with the duplicates value, what is the command? Union all is the command, okay. But we don't want the duplicate values, so we are removing union all. So that is one concept. Let's run this one. And these two queries which we run and did the union of it, it will get output for us, and from that output we have select everything as A. We have given the entire, this is another table which we have created, which we have given the name A, and order by we have done the employee number descending, and this we have selected, okay. Now we have gotten all the null values here, and we have gotten all these values here, okay. So just because we don't have any value which is in the first table and any column which is in the second table matching, so we are getting such output. Otherwise, if we have some matching values, then it will give us all those values as well, okay. So that is of about the union. Okay, now let's talk about except, union, intersect and union. Okay, so this is our first query and this is our second query. In these two query, whenever we perform union, we perform in the between. So when we run this completely, the first table will unite with the other. In union, I have already told you that the number of columns in the first will get added on to the next, and after that all the duplicates value will be removed. Okay, now let's talk about except. No, before except, let's talk about intersect. So intersect will only give us, if we use the intersect here, the intersect will only give us the value which are common. So whatever the common values will be there will be outputted out of it, okay. Then after that we have except. In except, all the values which are in this except these values which are in the common in this. So all the, in when we use the except, all the common values of these both queries will be subtracted from the above query. So you actually what we did is did the intersection of it, get the common values, and those common values will be subtracted from only this thing, okay. So that is the except. So this except whatever is in this, that is the except, okay. So these are the concept that we use, and I have explained you. Some I did there and some I did it. This is actually SQL, Microsoft SQL Server. So I am not performing the operation here of except. I am just trying to explain it to you what it does. You can practice it for yourself. As of now, I am just telling you like union and union all. I have told you the difference that in union all, both the values with the duplicate values are taken. In union, no duplicate values. In intersect, only the common values. In except, the accepting the second value, okay. Now this is union, except and intersect is done. Now we can move on to let's say to something in the Microsoft SQL Server. So let's see if there is anything left which we haven't discussed yet, which is we have done here, okay. Let's see superstore data first. Yeah, so okay, yeah, another thing which I remembered, Okay, let's go back to the assignment. I will tell you here. Check this query. Okay, so we have performed on join on these two pair table. So in these two table we haven't performed provided any aliases, like takes one and takes teaches two. We haven't performed any aliases. So if we don't provide any aliases, the entire name we have to provide while giving the select command. So takes one, I have to take takes one dot student ID, the which is the column inside it. And similarly I have to do all teachers dot name is equal to Morris and everything. Okay, the aliases we provide for our own ease so that we don't have to type as much. Otherwise, if we don't provide the aliases, we write the original name itself. Okay, I hope that clears this. And this is percentage Morris. Any if Morris is anywhere in between. This will give us error, I guess, because we use the like operator, not equals. Okay. Uh, okay. So now this is done. This is done. This is done. Yeah, this is another subquery, which is a little bit advanced subquery. Let's discuss this. So temperature temp is the, where are the two tables? Let's see. Here are the two teachers or teacher ID is equal to teachers ID temp dot teacher ID. So temp is this table. So this is one table and this is one table. So these two tables which we are taking, these are the two tables. We are performing the old join here. So in the old join we don't use on, so we haven't used on here. We just provided by comma, and after that where we perform the key join. Uh, yeah. After that, performing the key join, what we did, and okay, and teachers dot name is equal to Morris. So in the where condition, this condition it should be true, and this condition should also be true. So this works like this. So this is a little bit complicated to understand, but let's execute this. But we will get the output. Okay. Let's see if there is anything that I should tell you. Okay. Where salary is equal to, we can use equal to, instead of giving the value, we can use the entire subquery table instead of it and take out the value from it. So we will know that the maximum salary we will only get the one value of it. So one value is we will get out of it, and whatever the value we will get out of it will be taken, and it will be joined, not joined. Uh, uh, that everything will be outputted out of it. Let me tell you what I mean. So in the teachers table, these are all the columns and all the columns are getting out, but when we perform this, then only one column will be out. So it will check if this is equal to this, then it will give that column. I hope that clears something. And there is nothing else to explain here. We have the student execute, student table, instructor table, same thing, new tables. So we have teachers, salaries, many things, but I'm just trying to tell you the important new things that we create table. We have done insert values, we have done here same. Okay. That is a little bit lengthy. Yeah. So increase the salary of each instructor in the computer science department by 10%. So we checked what the instructor we have, ID, name, department name, salary we have. Okay. So we need another column name, new salary, where the salary is 10% incremented. So we do the calculation in the select statement itself. We don't use the, if we have to create a new table and on which we have to do some calculation, we use that calculation on the select statement itself. We don't use that in the where. Okay, just remember that. And the salary we will get as the new salary, and the new salary will be named as so it will be 10% more. So let's execute this query. So this salary, it has taken and multiplied by 10% or 1.1, and we will get the output. All these values are 10% extra, having this 10% extra salary. We can perform more conditions. Okay. Yeah. So this is done. Left join, right join is done. Let's see. SCI is done. Yeah, sciences should be in between. Salary, L salary. Oh yeah, case when then. Case when this condition is true, then do this. Else do this as new salary from instructor. Execute. Okay. This also works like that as well. So okay. So we have performed join instructor and department on department name. I max salary, minimum salary, sum of total salary. Okay. Another query. Okay. Let's see if there is something else. Yeah, distinct. So this one is very important to for you to remember. Let me execute this one and this one. Both I am executing at the same time, and I will tell you both. Okay, what we are getting out of it. Let's expand this one. Let's get it up. Yeah. So what we have done. So this is the result of the first, and this is the result of the second. In the SQL Server, we can output two queries at a time, or many queries at a time. But in the MySQL, we can only output one query at a time. So we have taken the distinct year. So years are the distinct, all the unique years will be get out of it. And we have used the sum of count of enrollment, which is the count of enrollment, and over we have used, I haven't explained you over. So in this one, let me tell you, when we use over, it is like group by. So it over order by year. So basically it is like group by, but it functions a little bit differently as group by. As running total from PQR. So PQR is the table, and if we perform this and run this, what we will get is it will group by all the all the rows from the year 2001 and total it. Okay, some of that it's provided here, and some of the next plus the previous one is provided here, plus the previous one is provided here. Actually, let's start from the down. We use the, instead of using order by, use the partition by. So what it will give, these are the okay, but the so yeah, let's okay. So this one, 2001 is the sum of all the 2001 year. This is the sum of all the 2002 year enrollment. This is the sum of enrollment in 2003, 4, 5, 6, so on. And above one is the sum of everything. Sum of this, it has calculated the same. Then sum of the second plus the first one is inputted out here. Then this all the three, then all the four, all the five, so on. So previous one is also getting added. So this thing we have done in Alteryx, and it is called the running total, and or it is also called the cumulative sum. So it does what we have done. We have done the sum here, and then we have added the sum. So if we want to add the sum, we do the cumulative sum, then we use over order by that as running total, because we know that the output will be the running total or the cumulative sum. So that is why we have done this like that. And if we do the partition by, then it will give the output of the like 2001 sum, 2002 sum, 3 sum, like that. Okay, I hope that explains well. Yeah. Okay. So let's say that we have to calculate the third maximum salary. Okay. So what we will do is select the top two salary from the instructor. So the top two salary will be outputted. Top two salaries, these are the top two salary from the instructor. Uh, Instructor we have ordered it, and we have ordered it by salary. So it will give us the top two salary which we are having. Okay. And then we use to select the max salary from the max salary, select the max salary as max salary from instructor table, where the salary is not in these two values. So not in these two values meaning it would be the third value, highest value only, because the top two values we have already selected from the instructor. So but wherever there is not these two values, we can output the third value. So this way we can calculate the directly calculated the third max salary, or the fourth max salary, or the 50th max salary, whatever the number we want. Okay. So this is another interesting SQL query. Okay, so let's see if there is anything interesting left to do. Count of distinct course ID, huh? Max of capacity, which we have discussed. Okay, so this one we have discussed. Let's go here. This one. Yeah, all these things we have discussed. These are okay. The same concept. To select the max salary from the instructor, salary not in top three. Select top three salary from the instructor order by. Okay. Previously we have done the top two, the same thing, or else we can write the salary in it, not in the range. It will give us the basically give us the range. So it is the explanation of this one. Yeah. Order by salary descending. Yeah, that is self-explanatory. Now moving to here. Yeah, another thing, we if we want to get the percentage out, like if we have some column in unit format, and we want the percentage format of it, so we can use that format, that column name, comma p, percentage. So it will automatically give us that number of percentage from it. Let me execute this one. So it has given us the 0th percentage, 10th, 15, all these percentage it has outputted from it. So yeah, that is how we calculate the percentage. Format, I mean, that is how we format the percentage. We have the discount value, and we just format comma p. It will give us the percentage or the percentage symbol at the end. It will make it a string, but it will give us the percentage. And then we have again format c. It gave us let's see what it gives. Yeah, it gave us the dollar. So format sum comma c, it gave us this dollar. You can look for the documentation of the format in the SQL Server. Yeah, maybe we will look later on, or you can look it for yourself. You can look at the format documentation in the for the SQL Server. You will find many other things as well. The way of formatting, which okay. Again, then this is the format p, the same thing, I guess. Percentage, yeah. So every what we have done here, select state we have selected as given the discount we have formatted. Okay, discount we have taken from orders. Profit is less than 0. Having average discount, again having whenever we use, when we use having, whenever we have to provide a condition, wherever we have to provide a condition in the aggregate function, we use having. Okay, let me tell you again. Whenever we use the condition with the aggregate function, we do that in having. Okay. Then this. Okay, so it will give all the values starting with anything two, starting with two, anything two values, and third value is a, and end with any value, number of values basically. So wherever there is in the third position there is a, it will give us that state in this case. Okay, so this, all these things are we have discussed already. There is nothing more. In the having, what we do, we use having. Yeah, we have already told you. Okay, so this is done. Yeah, now let's see if there is anything left. So top 100 I have already told you. Top we use before this, in the starting itself, before the number of columns we are describing. Okay, and these all things are done. Customer ID, customer name, sales, done. Yeah, we again have a query within a query within a query. Yeah, very nice. So let's in output select the innermost query. Average sales we have calculated. Then the second nested query, customer name, sales, customer ID we have calculated. Okay, let's see. So customer name, customer ID, sales we have provided. Sales is greater than the average sales. So wherever the average sales is greater than, where the sales is greater than the average sales, all these columns are outputted, and we just want to count them, how many of them are there. Oh, sorry. Execute. Yeah, maybe some error we are having. Count star, we can't do this. Okay. This is done, this is done, this is done. If exist, top table if exist. Yeah, another thing, into. I've forgotten to tell you into. Okay, moving back to assignment. Yeah, so in SQL Server, if we want to input a table in, get an output of a table, after getting the output of the table, let's suppose we have this. Okay, let me just write it here, and we know the output of this is like this, and we want that this output should go into another table. Where we write this, where we write that code is into code, after the columns, after we have selected the columns, into the table name, let's suppose triple Q. Okay, so this entire table will be inserted into triple Q. Execute. Now it is done. Now I can just simply select star from, okay, select star from QQQ. Yeah, so just run this, and that table output is inserted into this table. So that is how we use into. We use into after providing the column names. Always remember, and before from, but from before the from table, from in front of table. Okay, yeah. Okay, so this is another concept that I forgot to tell you before, and I just remembered. Let's see, I have told you round, if there is any concept left to tell. I guess I have told you every concept now. I have told you union, except, and union all, and intersection I have told you. Yeah. So finally let's go to the workshop which we had. Okay, so substring, what it does, you have to see the documentation first. Let's see. Okay, so it will check the substring, customer name, it will check the substring. Okay, 1,5. I have to see like what is substring itself before I tell you. Substring, so you can look for it, or let's search it, or wait, control. Okay, so what this substring does is take, yeah, first of all indexing. So in our string, the indexing started from 1. In our SQL, in our Python, it starts from 0. So remember, in SQL it starts from 1, and in Python it starts from 0. So the first, from first to 5, it will give the output of from the customer name. So it will check the customer name and it will just give the first 5 values. May it be space or not the space. So all the 5 values are getting out. Like in this meg, O is getting out. Like if the name is too large, like Tiffany, only Tifa comes out. So only 5 values we have taken out of it. Okay. Yeah. Then we have the concat function. In the concat function, we choose the state and the city, and we concat it, and with the hyphen which we have provided, and we also provide the space because we want the space in between. So state, this state, the state plus space plus hyphen plus again space plus the city. So that is how it is being outputted. Then the case when condition, which I have already told you. Let's execute this. So wherever there is 9, that is the else. Otherwise we have home office customer and corporate. Okay then. The date name, it will give date name. Year will get the year from it. Day will get the day from it. Weekday will get the weekday from it. And date name will get the date name from it. Okay. And select date name, day, order date into, I have already told you, into this table, so it will get this into that table. Yeah, so let's run this one as well. So order date we have taken 6 months, December, days. Yeah, so date name I have already told you. This is something that in this one, what we actually wanted is that we want the last 3 rows of the month from all the months. Yeah. So that is what we wanted here. Okay. So yeah, this is also done, and I guess everything is done now. Our SQL is completely completed. Drop table if exists, if a table exists, it will be dropped, which we have already done. And we have done the format function, we have done everything. Now I don't think there is anything left to be told. We have done all the aggregate function, min max, everything, all the wildcards we have done, and subqueries we have done, joins we have done, all the types of joins we have done. Basically we have done everything. So thank you all for watching this video, and this video got a little bit longer than I expected, but it is fine. So thank you for watching. Bye bye.